review of the Edgenuity lesson trigonometric ratios. Our three trigonometric ratios are sine, cosine, and tangent. And what we use these for is we use them to help us solve for side lengths of triangles and also angles inside of a triangle. So the way that I remember it is this saying here, SOHCAHTOA. Sine of our angle, so you'll notice right next to the sine, cosine, and tangent, those words always go with angle measures. And what happens is when you do sine of an angle measure, or cosine or tangent of an angle measure, what it gives you is a ratio of specific side lengths. So all of these fractions here go with the side lengths. So you do the word width of angle equals a ratio of side lengths. So the way that I remember it is sine is the opposite over the hypotenuse. That's what the SO stands for. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, your opposite and your adjacent are going to depend on which angle is your reference angle. So the hypotenuse, it's always the hypotenuse. It's opposite the right angle. It's always going to be the biggest side of your triangle. Now, let's say my reference angle was angle A here. That would mean this side over here is the opposite. So the one all the way across the triangle is the opposite. And the other one that's touching your angle, not the hypotenuse, but the other one, that's your adjacent leg. So that's how you come up with what these side names are. Now, if we were to switch and have B be our reference angle, then these two flip. Then this would become the opposite and this would be the adjacent. So for example 1, it says, find the sine, cosine, and tangent for angle A. So this is our reference angle that we're talking about right now. So that would mean all the way across is our opposite leg. The leg opposite the right angle is our hypotenuse. And then the other leg that's touching A, this is our adjacent. Oops, A, D, J. But we've got an issue. We don't have a length for the adjacent. So what we're going to do is, it's still a right triangle. We're going to do the Pythagorean theorem to solve for that length. So side squared plus side squared equals the hypotenuse squared. So if I solve this, I get 25 plus b squared. Remember, the hypotenuse is the one that goes by itself, not necessarily the unknown. Then I'm going to subtract 25 from both sides. So I got b squared is 144. Square root both sides, and b is 12 there. Okay, so from here we're just going to do SOHCAHTOA. So sine of A is your opposite over your hypotenuse. So I'm just following these ratios right here, SOHCAHTOA. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent, like that. So those are the trig ratios, for angle A. So then right here it says, now find sine, cosine, and tangent for angle B. So what I like to do is I like to redraw it, because I've already written all over that one. So I'll just make a rough sketch. We're doing the same triangle. So 13, 12, 5. Okay, so now we're doing it for angle B. So angle B is our reference angle. 13 is always going to be the hypotenuse because it's opposite our right angle. But now all the way across from the triangle from angle B is 12. So now this is our opposite, and the side that's still touching B is 5. So this is our adjacent. So sine of B, opposite over hypotenuse. Cosine for B is the adjacent over the hypotenuse. And the tangent for angle B is the opposite over the adjacent, like so. So if you don't have these written down, I would pause the video and get these written down. Okay, so a little bit they talk about 30, 60, 90 triangles and 45, 45, 90 triangles. We talked about this in a prior lesson, so it should be a little bit of a review. If you don't have these triangles drawn out with these lengths on there somewhere, you need to do that because we're going to end up using these over and over again here in the next couple of lessons. So as a reminder, when you're looking at lengths, the way the ratios work in 30, 60, 90 triangles is opposite of the 30 degrees is 1, the hypotenuse is 2, and opposite 60 degrees is root 3. So what I mean by that is if I had like 10 here, the hypotenuse would be twice as big, so it would be 20. And then this, like I said, it was 10, so this length over here would be 10 root 3. Remember doing that with the boxes? And then on 45, 45, 90 triangle, the legs are the same, and then the value of 1 here, and then the hypotenuse is taking that value and multiplying it by the square root of 2. So if this was 7, then this would be 7, and this would be 7 root 2. So for example 2 here, it says find the value of tangent y. So here's y. Tangent is going to be opposite over adjacent. So unfortunately for us, we don't have either of those values because all the way over here, this is our opposite length. This is our hypotenuse because it's opposite the right angle, and here is our adjacent. Okay, so because this is a 30, 60, 90 triangle, we know the hypotenuse is 4. So just like we have here, if our hypotenuse was 2, then we cut it in half to get 1 here. So if this length is 4, opposite the 30 degrees is going to be half as big. So half of 4 is 2, which would mean then the long leg, you just add a root 3 onto it. So this longer adjacent leg here, this is now 2 root 3. So now I can go tangent y equals opposite 2 over adjacent 2 root 3. Now you can simplify the 2's. So that becomes 1 over root 3. And then remember, you have to rationalize the denominator. So that's when you just multiply the top and bottom by whatever the denominator is. So 1 times root 3 is root 3. Root 3 times root 3 is 3. So tangent y is root 3 over 3. Okay, so now one with a 45, 45, 90 triangle. So we want sine of angle B. There's our reference angle. Sine is opposite over hypotenuse. Okay, so here's our hypotenuse, always across from the right angle. Opposite is over here. Adjacent is touching B right here. So opposite over hypotenuse. Again, we don't have any of those values. As a reminder, the 45, 45, 90 is an isosceles triangle. So if this leg is 5, this leg is 5. So now I know my opposite. And so I'm going to pull it back up here. If we have, so we had 1, 1, root 2. Remember I talked about if this was 7, then it'd be 7, 7, 7 root 2. So we have 5, 5. The hypotenuse on this 45, 45, 90 triangle will be 5 root 2. So sine of angle B equals opposite 5 over hypotenuse 5 root 2. So again, the 5 simplify to a 1, 1 over 1. Rationalize the denominator by multiplying the top and bottom by what the denominator is. And you will get root 2 over root 2 times root 2 is